G'day guys. So today we're going to be looking at compound interest, and we're going to start off by looking at it as a comparison between compound interest and simple interest. We've done simple interest before and we understand how that equation works. We take the principal, the rate, and the amount of times it's going to be calculated, and we get the interest amount. Compound interest works in almost exactly the same way, only it's the principal amount that's going to change each time. So I'm going to give an example. We're going to have the example of the principal is $500. The rate is 5% per annum. We'll just pretend it's per annum to start off with these examples, that's fine. And the time that's being invested for will be 2 years. So if we were using the simple interest equation, it'd be very simple. We could go, and I'm going to break this down by year, okay? So for the first year that that this money is invested for, it'll be 500 times 5 times 1 divided by 100. And this is going to be the amount of interest that we're going to earn. Remember, this is interest. And this is going to equal $25. For the second year, okay, the second year of interest, the simple interest equation doesn't change. We still have 500 times 5 times 1 divided by 100. And we get exactly the same result. Now when we ask, well, how much interest did we earn over the life of the investment? Well, it's simple. 25 plus 25 is 50. We got $50 out of our investment of 500 in this account. And that was the simple interest version. If we use compound interest, the principal is going to change. We're going to do the same version. We're going to use exactly the same details. So the principal is $500. The rate is 5% per annum, and the time is 2 years. It's calculated once a year for for 2 years. So compound interest starts off exactly the same. The interest amount that we're going to earn is equal to 500 times 5 times 1 divided by 100, which we know gives us $25. The second year of calculating interest, however, it's $525 times 5 times that year divided by 100. So compound interest adds on the last interest calculation's interest amount, and essentially it then calculates for a brand new principal. So it's kind of giving money for free, sort of in the real world. It doesn't quite work out so nicely. So this is equal to $26.25. And when we add those together and we say how much interest did we earn over the life of this loan, well, we have $51.25 that we earn. So we can see that by using compound interest, this is compound interest, this is simple interest, by using the compound interest equation, we actually get a better deal. Yeah, if we're investing for a compounded amount, we're going to end up with more money in the end because this just keeps increasing. So the following investment calculation will be $551.25 will be the principal, and then so on and so on and so on. So if we were to, there we go. If we were to look at a table comparing 10 years worth of simple interest versus compound interest, you can see the simple interest equation every single year, $25, $25, $25. That is the interest that is generated. The interest generated from the compound interest equation, wow, look at that. Goes up and up and up and up and up. And then by the time you get to the end of 10 years, there's a massive difference in terms of the final amounts of money that you're going to earn. So that's why the difference between compound and simple interest. Simple interest calculates it based on the principal that you invested every single year, just what you invested. Compounded interest compounds the money each calculation time period. So not necessarily each year, could be every 6 months, could be every week. And you end up getting a higher interest amount generated. So as you can imagine, you tend to find more compound interest equations being calculated for loans rather than investments. You tend to get a lot more loans trying to calculate your interest based on a compounded rate compared to calculating it on a simple rate. So let's talk about the compound interest equation formula. The formula now. And I'm going to change the formula. We're not going to use P times R times T, divide by 100, and have to do that over and over and over. This time we're going to go, it's going to be A, so the amount, the total amount in the account is equal to P multiplied by 1 plus the rate divided by 100 to the power of the time intervals. The equation looks very different now. It looks a lot more algebraic in its appearance. We're just breaking this down. So the P is just principal amount. Okay, that's the amount of money that you start with or that you invest. This part of the equation here, the R divided by 100, is converting your rate percentage to a decimal. Okay? So if you can do that already, if you see 5%, you know straight up that it's 0.05, then don't worry about the R divided by 100 bit. But for people who need this kind of assistance, then this is the equation. You're just going to put in 5 up here, divide by 100 down there. Now, this part of the equation, the 1 plus R divided by 100, is then not multiplied, but put to the power of the times calculated. Okay? Now that's a bit of a change in the... Oh dear. We'll just look at that. That's a bit of a change in how our equation works. We usually just multiply, and it's still multiplicative, but this is saying that it's no longer just increasing at a rate. Like if we have if that's amount of money and that's time, we no longer just have it increasing by a steady rate. The amount it's going to increase by is now exponential. Okay. Now the one plus, this is to make sure that we're actually increasing every single year by our original principal amount. Okay, so this is here just as a placeholder to try and make sure that our decimal is going to increase the amount of money that we have, not decrease the amount of money that we have. The next thing to note is that this equation will get you the final amount in your account. Okay, so this is your final account amount. Okay, it's not something that it's not just your interest that you're earning. It's not the interest that you're earning. It is going to be the final account amount. Okay, I'll make it clear that that is actually a 1, because at the moment it looks a little bit like my eyes. There we go. All right, so the equation is A equals P times 1 plus R divided by 100, so the rate divided by 100 to the power of T. Let's put this into practice now, shall we? Good old practice makes perfect. Timmy decides to deposit $500 at the Bank of Lewis. How much will his investment be worth after 15 years if it is compounded at a rate of 5% per annum? We start off by identifying the parts. The principal amount invested is $500. The rate of the investment is 5%, and the times that it is being calculated for, it's being calculated per annum, so every year for 15 years, that is 15 times. Now, it is being compounded at a rate of 5%. So this is our compound interest equation. A is equal to principal times 1 plus rate divided by 100 times time. Oh, sorry, to the power of time. Oof, nearly got that one horribly wrong. So that is going to be equal to 500 times 1, and I'm just going to do this part in my head. So, oh no, I won't. I'll extend it out so we can do it all together. So we can go 5 divided by 100, so that's 5% divided by 100 to the rate of 15, or to the power of 15. 500 times 1.05. So that is 0.05. 5 divided by 100 is 0.05, plus 1 will be 1.05 to the power of 15. And now we are at the stage where our calculation can be made. So 500 times 1.05 in brackets to the power of 15 into a calculator, we will get $1,039.46. Now that is the amount that we will have in the account at the end of the life of the investment. So hopefully this helps explain compound interest and the difference between compound and simple interest, and how to complete compound interest equations a fair bit better for you guys. All right, enjoy.